and this is t time period. T is the time period. Okay.
Okay, sir.
So from 0 to t by 2, the current is increasing first. From here to here, the current is increasing, then the current is decreasing.
Yes.
Now from t by 2 to t, the direction of the current reverse. Now here the direction is in upward direction, here the direction of the alternating current is in downward
Yes,
direction.
downwards. Yes.
And now you can see from this graph, as the time changes, the current is increasing now in negative direction. Finally the
Mm.
current become maximum. Now finally the current is decreasing in negative direction. So
Yes.
basically this is the alternating current. As the time changes, the magnitude as well as the direction of the current changes. Okay.
Okay.
So
Okay.
what is the source of the alternating current? AC generator. Okay. So next topic is
Okay.
AC generator or AC dynamo. So what is the AC generator? We know what is AC generator. AC generator converts the mechanical energy into the electrical energy. How the mechanical energy? Actually, when we will discuss the working of the AC generator, then you will know how the mechanical energy is converted into the electrical energy. Basically, in an AC generator, I think I have told you now. Then in AC generator there is one coil,
Yes,
and
sir.
that coil we
Yeah.
rotate
It
that
rotates.
coil.
Yeah.
We rotate that coil in a given
It has slip
magnetic
rings.
field. Yeah, in a given magnetic field, and according to the Faraday law, induced
Yes.
EMF will be there in the coil, and due to that there will be induced current. So first we should know what is the principle. This is theory. So it is based on the Faraday law of electromagnetic induction. We know what is the Faraday law of electromagnetic induction, which says that whenever the magnetic flux linked with the coil is changed, the EMF is induced in the coil. I have told
Yes.
you what is for a Faraday law. Whenever
Yes, sir.
there is a change in the magnetic flux, change in magnetic flux linked with coil, okay, then
Yes.
induced EMF induced in that coil. Okay,
Okay. Yeah.
Faraday law. So basically, actually what happens in a AC generator, what happens in a AC generator basically, there is, you can imagine, there is magnetic field in this direction, like this. These are the magnetic field lines. Okay,
Yes.
if you are
Okay.
able to imagine. Okay, so
Yes.
you can say this is the direction of the magnetic field. Okay, this is the direction of the magnetic field, and you have one coil, and this coil, this coil is rotating in a magnetic field by some any external agent, external force. This coil is rotating.
Yes.
So what is happening here? I have told you the direction of the magnetic field is fixed. Magnitude and
Yes.
the direction of the magnetic field in an AC generator be kept fixed. But what happens? I have told you the concept of the area vector. I have told you now what is the area vector. Area
Yeah.
vector is perpendicular to the coil. So
Yes,
area
sir.
vector will be when the coil is like this. Suppose initially the coil is like this. So direction
Yes.
of the area vector is this, in this direction.
Yes.
Direction of magnetic field also in this direction. So
Yes, sir.
theta is equal to 0 degree. Okay, so
Yeah.
what will happen? What will happen when this coil will rotate like this? When the coil will rotate, the direction of the area vector will change. Initially, the
Yes.
direction of the area vector is this. Now this
Yes.
coil is rotating like this. Means the direction
Yeah.
of the area vector is changing.
Changing. Yes.
No. If the direction of the area vector is changing, we know that I have drawn this diagram to explain how the direction of the area vector is changing. So this when the coil is rotating, the direction of the area vector is changing. So actually, what is theta in the magnetic flux? I have told you the magnetic flux is given by BA cos theta.
Yes.
So what is theta?
Be.
Theta is the angle between the, here you can see theta is the angle between the magnetic field and the area vector. And when the
Yes.
coil is rotating, the area vector is changing, direction of the area vector is changing. So you can say
Yes, sir.
this separation or this theta is changing.
Yes, sir.
This theta is changing. Okay, so if this theta is changing, so you can say your cos theta is changing, because at
Yes.
different value of theta, the cos theta will be different. Then you
Yes.
can say your magnetic flux is changing. Your magnetic
Yeah.
flux is changing. So you can say the magnetic flux of this coil changing. So what will happen when the magnetic flux changes? Induced EMF will be there in this coil.
Yes.
According to the Faraday law, change in magnetic flux produces the induced EMF. Change in
Induced EMF.
magnetic
Yes.
flux produces the induced EMF. So this is change in magnetic flux with respect to time. Time is changing. Time is
Yes.
always changing. So basically, here is flux changing with time will give you the EMF. This is
Yeah.
what the Faraday law says. So basically, in this coil, the magnetic flux linked with the coil is changing. That is why induced EMF will be there in this coil. So this is the basic concept of AC generator. Okay, so after that, we will see what is the components of the AC generator. What is the construction of the AC generator? So construction is this.
Yeah.
Basically, these are the field magnets.
Yes.
These are the field magnets. And what is the work of magnets to produce the magnetic field? So
Yes.
basically, due to these magnets, this is the magnetic field in this direction. So basically, these are representing the magnetic field lines, and here is your coil, and
Yes.
this coil is rotating with
Yes.
some angular velocity omega. This coil is rotating, and this
Yeah.
coil is rotating in the magnetic field. Okay, so there will be the magnetic flux in this coil I have described, and this coil is also known as armature.
Armature. Yeah.
And this is the axis of rotation of armature. Axis of
Yeah.
rotation. Okay. Field
Okay.
magnet. Okay. So here is one rod structure, and from that rod structure there are slip rings. These are the
Yes.
slip rings. Means these rings can slide on this rod.
Yeah.
Okay. And these are the brushes, and
Yeah.
this is the load connected. So finally what is happening in this coil, there is the induced EMF, and due to that induced EMF there will be the induced current in this coil, and this through this slip rings and through this brush the current is going in the load.
Yeah. Yes.
Basically current is going in load can be your laptop, load can be your electric bulb, load can be any device. Okay,
Yes.
heater can, you can say heater as a load.
Okay.
So yeah, so basically what is happening, mechanical energy means you are applying a force on this coil and this coil is rotating, means you are
Yes.
giving the mechanical energy to this coil, and in return this whole AC generator is giving the current means the electrical energy it is giving. So here what is
Yes.
happening, mechanical energy is converting into the electrical energy.
Yes.
Okay. So basically capital N is the number of turns of this armature. There will be the number of turns. A, I am representing area of the armature. B is the strength of the magnetic field. This is the magnetic field. Omega is the angular velocity of the coil. Omega is the angular velocity of the coil or armature, you can say. Okay,
Okay.
so flux linked with coil. Uh, we know that magnetic flux linked with the coil is given by VA cos theta,
Yes.
and
Yes, sir.
theta we know.
Yeah. Angle
Okay,
between
so and
yeah.
I have told you there is a relation between the angular velocity and theta. Angular velocity is theta divided by t. Theta is the angular displacement. Theta will be here. This is the theta. Okay.
Yes, sir.
So I am showing
Yeah.
theta here. Okay. I am showing theta here. So basically this theta is changing. So this magnetic flux I can write. I can write this magnetic flux phi is equal to VA. Instead of theta, we can put omega t,
Yeah. Yes.
cos omega t.
Yes, sir.
So this is your magnetic flux. Now, according to the Faraday law, you know that
Minus
EMF is given by d phi by dt.
d by dt. Yes.
So you will differentiate this equation. D by dt. This will become. You will put the
Minus.
value of phi here. VA cos omega t.
Yeah.
So now this VA is constant, magnetic field is constant, not changing. Na
Yeah.
magnetic field direction and the magnitude both are same.
Yes. Yes.
Area of the coil not changing, same.
No.
So
Yes.
means both of these are constant. So we can
Yes.
take this out of the differentiation. So now basically we will do the differentiation of cos omega t. So differentiation
Minus
of
sin omega t.
yeah, very good. Cos omega t is minus sin omega t.
Yes.
Sin omega t, and now you will differentiate again this omega t.
Omega
So
t.
you will get omega.
90.
You will
Yeah.
get omega again. So now this minus and minus plus.
Yes.
So we can write this B A omega sin omega t.
Sin omega t.
So EMF induced in this coil is given by VA omega sin omega t. Okay,
Yes.
so N is the number of turns in the coil. So total EMF induced by the coil. Suppose this is your E1. You can suppose this as E1. Okay.
Okay.
E1 means this is the EMF induced due to the one turn of the coil, and due
Okay,
to
sir.
the N, and there are N turns in the coil. So due to the
Yes.
N turns in the coil, the EMF is given by NVA omega sin omega t.
Yeah.
So basically, to this equation, we multiply by capital N.
Okay.
So we will get
The number of
this.
turns.
Yeah. So this is
Okay.
the EMF induced in armature. So this is your equation of EMF. This is your equation of EMF.
Yeah. Yes.
So basically, this equation you are getting. Now I have told you the graph of alternating current. So
Yeah.
basically, this is your alternating EMF. This is your alternating EMF, and
Yes.
alternating current also be in the form of sine. Alternating current will also be in the form of sine. So that is why we have seen here. That is why we have seen here that here you can see that the current is in the form of the sine curve. The curve
Yes.
of the current with time, or the graph of the current with time, is this is basically the curve of sine. Okay, this is the
Yes.
curve or the graph of sine. Y is equal to sine t. So this EMF is in the form of sine, na? So we
Yes.
can write this is sinusoidal variation for E. Okay, due to this sine. The maximum value of sine omega t is 1. The
Yeah.
maximum value of sine, you should know, is always equal to 1, and the
Yeah.
minimum value of the sine is equal to minus 1. So if
Hmm.
I want this EMF to be maximum, and what is variable here? This omega t is variable.
Omega t.
Omega t means this omega is constant, this time is changing.
Yes.
So due to change in time, the sign will change. And
Yes, sir.
if I want to calculate the maximum value of sine, then maximum value of sine is +1, and minimum value of sine is -1. So I am talking about the maximum value. So for maximum EMF, so this EMF is depending upon the sign. So you can
Yes.
say this EMF will be maximum when this sign will be maximum.
Yeah.
So you can put the value. This this value you will get when you will put 1 here. You will get E is equal to NB A omega into 1. So this will become E max. What is E max? Maximum EMF induced in the coil. So NB A omega will be the E max. NB A omega will be the E max. Now this equation can be converted. This NBA omega can be written as E max.
Yeah.
So this equation will become E is equal to E max sine omega t. So we will get this
Yeah.
E is equal to E max sine omega t. So EMF at some time t. So basically EMF at some time t is given by E max sine omega t. What is value of E max? NBA omega.
Yeah.
So if you will draw the curve of the, if you will draw the graph of this EMF with respect to time, then it will be of sine curve. It will be of sine curve in this form. You can see this is same as that of current now. This is same as that of current. So basically that is why the that is why I have drawn there the alternating current, or alternating current is changing with respect to time. So
Yes.
okay, so this is your
Okay.
alternating EMF. This is your
Yes.
alternating EMF. The graph of the alternating EMF is also will be the sine curve. So basically, this
Yeah.
representing the time. This representing the time t by 4. This representing the t by 2. This representing the time period t. What is the meaning of time period? Coil is rotating in the magnetic field.
Yes.
Coil is rotating in the magnetic field.
Yes.
And when the coil completes the 360-degree rotation, that time taken by the coil is known as the time period.
Okay.
Okay. Time taken by the coil to complete one rotation. So this will be the graph of this. So there is one question, very easy question. A man pedals a stationary bicycle. The pedal of bicycle. Okay, the pedals of bicycle are attached to a 100-ton coil of area 0.01 meter square. Okay, and the coil rotates at half revolution per second. Basically there is one coil.
Yes.
Basically there is one coil, and that coil has number of turn is equal to 100. And what is
Yeah.
the area of the coil?
0.10 meters square.
Yeah, 0.10 meter square.
Yes.
The coil rotates half a revolution per second. Remember one point. There is a term frequency. There is a term
Frequency. Yeah.
this frequency is number of revolutions made by coil in 1 second. Means frequency is the number of revolution per second. In 1 second, how many revolutions the coil is making? That is the
Yes.
frequency. So you can see per second half revolution. So frequency is half.
Yeah.
Unit of frequency is hertz.
Hertz. Yeah.
Hertz.
Yes.
Okay.
Yeah.
And it is placed in a magnetic field. Now this coil is placed in the magnetic field
Yes.
0.01 Tesla, perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? What is the maximum voltage generated in the coil? They are saying that the coil is placed in a magnetic field. The coil is placed in a magnetic field.
Yes.
Magnetic field, and that magnetic field is perpendicular to the axis of rotation of the coil. So what is the meaning? suppose this is your coil. There will be some axis of rotation of this coil. Suppose this coil is rotating like this.
Yes.
So the axis of rotation of the coil will be in this direction, in upward direction, or in upward, or you can say in vertical direction, like this.
Yes.
And magnetic field is like this. Magnetic field is like this. So basically, and this coil is rotating in the magnetic field. This coil is rotating in the magnetic field.
Yes.
Coil is rotating like this in a magnetic field. So what happens whenever a coil rotates in a magnetic field? EMF induced in that coil. EMF induced in that coil. Okay.
Yes,
EMF induced in that coil. What is that EMF? E is equal to E naught sine omega t. This will be the induced EMF. And what is
Yeah.
this E naught? Maximum EMF,
Yes.
or you can say maximum voltage. So basically they are asking this maximum voltage E naught. So what is E naught? NBA omega. Is it or not? E naught is
Yes.
NBA omega, na? Here you can see.
Yeah.
E max is equal to NBA omega. So I have written it like E
Yes.
naught. Okay.
Okay.
So okay, I have to write in terms of E max. So it is okay, na? E naught. E naught is also the maximum EMF. Okay, so now put the value, number of turns 100, magnetic field 0.01, area 0.10 meter square, frequency half. Okay, you will get this in volts. You will get this in volts.
So if we divide by 100,
no, this 100. No, why we will divide by 100? Because the formula is NBA omega.
okay, yeah. Okay.
So I am just putting the value according to this formula. This N is 100 here, so that is why. If you will divide, okay, you are saying that what will happen?
Yeah.
Okay. If we will divide by 100, then we will get the EMF induced for one turn of coil.
Okay.
For one turn of coil. Okay. Actually,
Okay,
basically, practically the coil is in like this. There are
Yes,
the turns of the wire in the coil. If you will see it, wire. So one turn is producing the EMF this VA omega, and there are n turns in the coil. There are n turns in the coil. That's why we are multiplying this n here.
Okay.
That is why we are multiplying. This can also be the answer. If you can just see this. If you will put in this formula as n equal to 1, then what you will get? E is equal to 1 into VA omega. So basically this will be the EMF induced for one turn of the coil.
Okay, sir. Okay.
Okay, so basically now revision. Equation of alternating EMF. E is equal to E naught sin omega t. What is E naught? Maximum value of EMF or peak value. This is known as the maximum value of EMF or peak value of or amplitude of EMF. And what is E? Instantaneous EMF.
Yeah.
Instantaneous EMF means EMF at an instant of time, because with time the EMF is changing.
Yes.
And what is omega? Angular velocity. And what is t? Small t is the time.
Yes.
Okay, so now write down, just a minute, I'm zooming it out.
Okay. Done, sir. Done, sir. Done, sir. Done, sir. Done, sir.
Done this?
No, sir.
Okay, take this.
Done.
Done. Okay. So
Yeah. Done, sir.
oh, there is one problem
Yes, sir.
actually in this question. Frequency is given,
Yeah.
and in this formula there is the omega, and we have directly put this value. So we will first calculate omega, then we will put omega is given by 2 pi f. So this will be your 2 pi f is half. So what will be your omega? Pi radian per second. So basically here you will put pi. So your answer
Okay.
will be 0.314 volts.
Okay. Yeah.
So this is your angular velocity, this is your frequency. Now you can take the screenshot.
Okay, sir. Done, sir.
Okay. So take this screenshot.
Done, sir.
So basically what is happening, the EMF, this is the graph of the EMF, and this EMF is changing with time. This is the equation
Yes.
of the EMF, and this is the graph. So EMF is changing with time. As the time
Yeah.
passes, the EMF is changing. So what we do now, we calculate the average value. We calculate the average value of this EMF. At every instant of time, the value is changing. At every instant of time, the value is changing. So
Yes.
this value is changing. So that is why we calculate the average value. Okay. So first we will calculate the average value of EMF for full cycle. For full cycle means for the time period of 0 to t.
Yeah.
Full cycle means the coil is rotated through 360-degree, and for that time we will calculate the average value of EMF. Average value of EMF
Okay.
for full cycle. So basically this is the graph. Okay, so we know average. If I am giving you three numbers like 1, 2, 3, and I am saying calculate the average,
Yeah.
then you will do 1 plus 2 plus 3 divided by 3, means sum of
Yes.
number divided by numbers of number. Numbers of, okay. But
Okay.
what is, and this concept is valid for here, this we can add directly 1 plus 2 plus 3.
Yes.
Okay, because these are the constant values. These are the constant values, but here this EMF is changing at every instant of time. So we cannot calculate the average of this like this. Okay.
Okay, sir.
So that is why we will take the help of the integration. And suppose if you have a function y is equal to fx, and you want to calculate the average value. Average value is represented like this, or like this, or like this also, y and this bar. So average value you want to calculate. Suppose this is your function in terms of the y, and you
Yes.
want the average value for this function for x0 to 5. For x0 to 5, then how you will calculate? You will just first integrate this function with respect
Yes.
to x from 0 to 5 and integrate the dx with 0 to 5.
Yeah.
Okay, so basically you can see this is the sum of the values of the function at different time, and this is the sum of the x values that you are putting in the function. Okay, so basically
Okay.
we will apply this thing here. I want to calculate the average value of, so average value I am writing like this. Okay, you can write the average value of EMF like this, or you
Yes.
can write the average value like simply like this, in short.
Okay, sir.
So we want to find the average. So how we will find the average? And we want the average for full cycle. For full cycle means for time 0 to capital T. So we will integrate this. We will integrate this E naught sine omega t for 0 to t, and after that we will integrate this dt for 0 to t. Now here this E naught is the maximum value. E naught
Yeah.
is the maximum. E naught is given by NVA omega. Number
Yeah.
of turns in the coil is constant, magnetic field is constant, area of the coil is constant, angular velocity of the coil is constant. So
Yes.
basically this E naught is constant. So you can take this E naught out of the integration, and you will integrate this sine. And what is the integration of sine? Integration of sine, suppose you are integrating this sine omega t.
Cos I
Yeah,
minus.
this will become minus, not minus cos. This is become minus cos. Okay,
Yeah.
this is minus cos omega t,
Yes.
and in denominator you will get omega.
Okay.
So basically integration will be, and if you are applying the limit from 0 to t, then here also you have to apply the limits 0
Yes.
to t.
Yes.
So basically this will be minus cos omega t divided by omega, applying the limit from 0 to t. So you will get E naught by omega, and you will put the value, and minus you can take the here. So this will become, first you will put here in this cos omega t this value of the t. So this will become cos of omega into capital T minus cos of 0. So this is minus E naught by omega cos of omega. Omega is given by 2 pi by t. Omega is given by 2 pi by t, and here is t. So this is cos 0. This t and t will be cancel out, so this will become cos 2 pi.
Yeah. Yes.
So E naught by omega, and cos 2 pi is 1 and cos 0 is also 1. So 1 minus 1 is 0. So this
Yes.
whole value will become 0. So what is
Yes.
the average value of EMF for full cycle? 0.
Hmm.
So for full cycle, the average value of EMF is 0.
Zero.
Now if you want to calculate the value for half cycle. Half cycle means from time 0 to t by 2. Half cycle
Yeah.
means when the coil is rotated through 180 degree.
Yes.
So average value of EMF for half cycle. for half cycle. So for half cycle, what you will do? For half cycle, what you will do? This is the equation of the EMF.
Yeah. Yes. Sir.
This is the equation of the EMF, and for you want to calculate the average value for half cycle. Half cycle means 0 to t by 2 time. So you will do the average of this E naught sine omega t basically. So how we will calculate the average? We will integrate this function from 0 to t by 2,
Yeah.
because we want the average from divided by dt 0 to t by 2. Okay, so after that E naught will be constant. Now integrate this sine omega t is minus cos omega t, and here is one omega also, and limit of integration will be 0 to t by 2, and in denominator you will have t by 2.
Yeah.
T by 2. So basically you will get this value. After that
Yes.
you will put the value of limits. So this will become 2 e naught by omega t. Now put the value, and this here is minus sign also. So here when you will put cos omega instead of t, you will put this t by 2, and this will become cos 0 degree. And I have told
Yes.
you omega is equal to 2 pi by t.
Yes. Sir.
So this will become minus 2 e naught by omega t, and this is cos omega is 2 pi by t, na? Omega is
Yes.
2 pi by t, and here is your t by 2. This is your cos 0 degree. Now this t and t will be get cancel out, and 2 and 2 will get cancel out. So you will have this minus 2 e naught by omega t, and here you can also put the value of t. Here also you can put the value of t. T is equal to 2 pi by omega. T is equal to 2 pi by omega. So basically here you will have this cos and pi, and cos pi is minus 1 and cos 0 is 1.
1. Yeah.
So basically you will get this minus 2. This will become minus 2, and here
Yes.
is okay, this will become minus 2. So basically you will have minus 2 e naught. This omega and omega is cancel out. So in denominator you will have 2 pi, and here you will have minus 2. So this 2 and 2 will be cancel out. So basically minus minus plus. So finally you will get 2 e naught divided by pi. So this will be your average value of EMF for
Yes.
0 to t by 2. For 0 to t by 2, the average value is 2 e naught by pi. 2 e naught by pi you
Fine.
will get. And when you will calculate this value, so this value will come out to be 0.637 e naught.
Yes.
You will divide this 2 by pi, so you will get this value. So basically for half cycle, the value of the EMF is this.
Yes.
This is the EMF for half cycle. This is the value of the EMF for full cycle of AC. Okay, so there is one more concept. We first note down this, then we will discuss that.
Okay. Sir. Done, sir. Done, sir. Done, sir. Done, sir.
Done. Okay.
Yes. Done, sir.
Done.
Yeah.
Then there is one more concept, root mean square value. Root mean square value, RMS value. Now see what is this root mean square value. Just a minute. This is not working, so I have to. So root mean square value. So if you have a function y is equal to fx and you want to calculate the root mean square value of this function,
Yeah.
then first you will do the square, then you will take the mean, then you will take the under root. Okay, square, mean and under root. Mean means average. Mean means average. So for example, suppose if you have the values a, b and c, three values you have, and of
Yes.
these three values you want to calculate the root mean square. You want to calculate r
Root
m
mean square.
s. So you will go in this direction. So first you will do the square. Square means you will do this. Okay, this will become a square, this b square, this will become c square. Then you will take the mean. Mean means average. You will take the average of a square plus b square plus c square. This will become this. So this is the
Yes.
average, no? A square. Then after that you will take the under root of this. So this will be the RMS, root mean square value. This root root mean square value. This thing is valid when here A is constant value, B is constant value, C is constant value. But we have
Yeah.
the alternating EMF. This alternating, we want to calculate the root mean square value for alternating EMF, but alternating EMF is changing with
Yes.
time. So we will use the integration for that. We will use the, first we will take the square. Okay, first we will take the square. See
Okay.
here, suppose for example, this is my function y is equal to fx. Okay,
Yes.
this is any function y is equal to fx. So I want to find the root mean square. So first I will do the square of y.
Yes.
Then I will take the mean of y. Then I will take the root of y. So what will be this? This will be y RMS.
Okay.
Now root mean square value we want to find for this. So first we will do I want to find ERMS. So first we will do the E square, then
Yes.
I will take the mean, then I will take the under root. So now put the value. This is under root, and E square means this E naught, this is square. Okay, E naught
Okay.
square sine square omega t. So here you will put E naught square sine square omega t, and you will take the mean of this. So how we calculate the mean of any function? Suppose I want to calculate the mean of y, or you can say average. This mean is also known as the average value. So what we do? We do the integration for the time. Suppose 0 to t time I want to calculate
Yes.
here will be your y into dt, and here will be your dt 0 to t. Okay, so this value is the average of E naught square sine square omega t. So here this E naught is constant. This E naught is constant. So you can take this out of the. So do one thing. Take the
Hmm.
integration from 0 to t of E naught square sine square omega t. I can write this like this, na, to the power half, because this is under root, na. So under root
Yes.
can be
Yes.
written as whole to the power half.
Yes.
Okay, now
Yes.
basic, and here we have one more thing. This is dt. Here, this dt will be 0 to t.
Yeah.
This dt will be 0 to t. Okay, so now whole power half. This is the integration, so E naught square will be out of the integration. So E naught square will be out of the integration, and now we will
Yes.
do the integration of 0 to t sine square omega t divided by this will become t.
Yes.
This will become t, and this whole power have the power half. Now integration of sine omega t, integration of sine square omega t, we will convert. For that we have to convert this sine square omega t. See, sine square omega
Yes.
t can be written as 1 minus cos 2 omega t divided by 2 from this formula of cos 2 theta. Cos 2 theta is given
Yes.
by 1 minus 2 sine square theta, or 2 cos square theta minus 1. So from this to this, when you will convert this formula, you will get sine square omega t as 1 minus 2 cos 2 omega t. Okay, so for this
Okay.
sine square omega t, you can put this is your E naught square, and this is the integration 0 to t sine square omega t can be written as 1 minus cos 2 omega t cos 2 omega t
Yes.
divided by 2. Okay, and here is dt, and here is dt also.
Hmm.
And here is your t,
Hmm.
and this whole power have 1 by 2. Now after that, this is E naught square by t, and this can be written as half of dt integration of,
Yeah.
you can write this 0 to t, this can be written as half of dt minus, you can write this as half of cos omega t from 0 to t, and this is dt. This can be written like this also.
So you
And
took half and dt inside the bracket.
yeah, this 1
Okay.
by 2, na, I have written this
Yeah.
1 by 2. This is the
Okay.
integration.
Okay.
Integration
Yeah.
of 1 by 2 into dt minus
Okay.
half 1 by 2 of cos 2
Yeah.
omega t. Here is cos
Okay.
2 omega t, not omega
Yeah.
t.
Okay.
Cos 2 omega t. and this is your bracket, and
Yeah.
this whole power have 1 by 2.
Okay.
Now this is E naught square by t. The integration of dt will be t, and when you
Yeah.
will put the limit t minus 0, so you will get t. So you will
Yes.
get half of t
Half
minus
of it. Yeah.
half. Now you will integrate cos 2 omega t. So I am
Yes.
integrating here cos 2 omega t, 0 to t.
Hmm.
So
Yeah.
cos 2 omega t, integration of cos is sine. So here you will write sine 2 omega
Same.
t divided by 2 omega,
Yeah.
and you will put the limit 0 to t.
Yeah.
Okay, so basically you will get here, you will get sine 2 omega t divided by 2 omega from 0 to t, and this whole have the power of 1 by 2.
Yes.
Now this is E naught square divided by t, and here we will have half of t, and here we will have half. So you will multiply this 2 with 2, so this will become 4 into omega. This will become 4 omega. Now you will put the value of the limit. This is sine 2 omega t, sine 2 omega t, sine 2 omega into t. So this will become sine 2 omega t minus this. This is 0. So when you will put 0 in this equation, this will become sine 0.
Yeah.
This
Yes.
whole power have 1 by 2. After that, you can write this as E naught square by t. This is your half of t. This is minus 1 by 4 into omega. And now here you see, this is your sine 2 omega. You can write 2 pi by t. Here is also t. Here is sine 0 is 0.
Yeah.
Sine 0 is 0. So basically, this will have the whole power of 1 by 2.
Yeah.
So this will become also 0 because this t and t will be cancel out. This will become
Yes.
sine of 4 pi, sine of 1 pi, 2 pi, 3 pi,
Yeah.
4 pi, all 0. So this is
Yes.
0, this is 0, 0 minus 0 is 0, and this whole thing will become 0. Okay, this whole thing
Okay.
will become 0. So you will have only this thing, E naught square by t into half of t and whole power 1 by 2, or you can write this as under root.
Hmm.
1 by 2 can be written as under root, or under root can be written as 1 by 2. So this t and t will be cancel out, and under root of E naught square will become E naught, and
Yeah.
under root of 2 will become root 2. So
Yeah.
basically this is your ERMS.
Okay.
Root mean square value is E naught by root 2. So this derivation is lengthy, but
Yes.
we can do this derivation in a very easy way also, that I will tell you later. Okay, so
Okay.
okay, take the screenshot.
Done. Done.
Okay, just a minute, just a minute. This thing, na,
Yeah. Yes.
this thing I have written separately.
Okay.
Okay,
Okay.
this is separate thing.
Hmm.
You can write here. Okay. Now take the screenshot.
Okay. Done. That's
Now there is one numerical, very easy numerical. This is your numerical. Hmm. So we will solve this numerical. They are asking equation of alternating EMF is given. This E is equal to 10 sine 314 into T. So what is the standard equation of EMF? E is equal to E naught sine omega T. So now compare both the equation. So when you will compare E naught, you will get 10. 10 volts you will get. And this is sine omega. From here you will get 314 radian per second. So answer first now.
okay. So
Peak value is E naught. E naught is also known as peak value. So peak value, right? E naught is equal to 10.
Okay.
Answer second. They are saying average value for full cycle. What I have told you, average value for full cycle? 0.
Yeah.
See here. For full cycle,
Yes, sir.
average value, this is the average value.
Yes.
This is the average value. For full cycle, 0. Any function,
Yes.
value of average value for alternating EMF equal to 0.
Yes.
So average value of for full cycle means you can write this as E average. Okay, for full 5 cycle is equal to 0. Answer third. Average value for half cycle. See here for the half cycle. For half cycle, you will get this value 0.637 of E naught, or you can write 2 E naught by pi.
Okay.
So E average for half cycle is equal to 2 E naught by pi. What is E naught? 10.
Yeah.
So you will get 20 by pi volts. After that, they are asking what is angular frequency. We have already calculated angle. This is also known as the angular frequency. Angular velocity is also known as angular frequency. Answer fourth. So angular frequency omega is equal to 314 radian per second. Fifth, RMS value of EMF. RMS, root mean square value. RMS value is given by peak value divided by root 2. We have just calculated in the last derivation.
Yes.
ERMS is equal to E naught by root 2. Okay. E naught is given as 10. E naught is 10. So your answer will be 10 by root 2 volts. Sixth, EMF at T is equal to this. T is equal to this value. So we have the equation of EMF this, and I have told you this equation will give you the EMF at any instant of time. So they are asking EMF at this instant of time.
Yeah.
So put the value of T here, you will get your answer. E is equal to 10 sine 314. Instead of T, put this T. Pi divided by 6 into 314. 314 and 314 will be cancelled out. Here will be sine pi by 6. So value of sine pi by 6 is 1 by 2. So what you will get? E is equal to 10 into 1 by 2. So basically what you will get? E is equal to 5 volts. Have you written this RMS value?
Yeah. Yes. Done. Done.
Okay, so average value or average value can be written like this also, E and this thing. In NCERT they have written like this, or you can write the average value of EMF like this. Not this is a vector, this like this only.
Okay.
E bar. So if I am talking about the average value for full cycle, for full cycle, what is the meaning of full cycle? 4 times 0 to capital T. What is capital T? Time period.
Time period.
So average value for full cycle you can write in any of the way is equal to 0.
Okay.
And what is the equation of EMF? E is equal to E naught sin omega t. Okay. What is
Okay.
E? E is the EMF at any time.
Yeah.
What is E naught? Maximum value or peak value of EMF. What is omega? Angular velocity or angular frequency.
Angular.
What is T? T is the time.
Yeah.
Okay. For half cycle means 4 times 0 to T by 2.
Yeah.
You will get average value of EMF 2 E naught divided by pi,
Yeah.
or 0.637 of E naught. Okay, so RMS value we calculate for 0 to T time na, for full cycle.
Yes.
So what is ERMS? ERMS is given by peak value divided by root 2. If you want to calculate the average value for any function, suppose there is a one function y is equal to fx. If you want to calculate the y average, then what you will do? You will take the average of this, like you will integrate this 0 to t.
Yes.
If you want to calculate the average value of this function for 0 to t time. Or not 0 to t, because this is a function of x. So suppose I want to calculate it for 0 to capital X. So
Yeah.
here integration of the limit will be 0 to capital X divided by, here will be your dx, divided
Yes.
by dx 0 to capital X. So this is your revision. Okay. After that, equation of the alternating current is same as that of equation of EMF. So this is the equation of alternating current. I is equal to I naught sin omega t. What is the equation of alternating EMF? E is equal to E naught
E naught sin.
sin omega t. So
Yeah.
equation of the current. And what is I? Instantaneous value means the current at any instant of time.
Yeah.
Okay. I naught is the peak value or maximum value. Omega, I have told you, time. And if you will calculate average value of current for full cycle, then also you will get 0. If you will calculate average value of current for half cycle, then you will get 2 I naught by pi.
Yeah. Yes.
If you will calculate the average root mean square value of the current, then you will get again I is equal to I naught by root 2. So what is the EMF for the full cycle? 0. What is the EMF, average EMF for full cycle? Not for half cycle, 2 E naught by pi.
Yeah.
And what is the EMF, ERMS? ERMS for full cycle is given by E naught by root 2. So both the equations are similar. You can see this is 2 I naught by pi, this is 2 E naught by pi. Okay, here you will get I naught by root 2, here you will get E naught by root 2. For half
Yes.
cycle, the current value is 0, alternating current value is 0. For half cycle, the EMF value is 0. Got it?
Yes, sir. So can you go to the previous slide?
RMS value or this?
Yeah.
This one.
Yeah, this
So
one.
I'm
Yes.
just a minute. Suppose suppose there is a question like this. Question is find average current, and the equation of current is given as I is equal to I naught plus I naught sin omega t. This will be the condition. Or you can take that your previous question. You can take your previous question. In the previous questions, in the previous topics, what we have done, we have the equation of EMS is ER. Equation of EMF is equal to E is equal to E naught sin omega t.
Yes, sir.
Okay, for full cycle, if I want to find the average value of EMF, okay, average value of EMF, so I can write this like this. So I can write the equation E naught sin omega t. Okay. Now you have to take the average of this, na? This is the shortcut I am telling you. That method of integration is lengthy as compared to
Yes,
this.
sir.
So what you will do, this E naught is the constant value.
Yeah.
E naught is the constant value, and if you will take the average of the constant value, again you will get the constant value. Suppose you have 2. You want to calculate the average of 2. 2, 2, 2, 2. You can take any number of 2's. So do this 2 plus 2 plus 2 plus 2. How many
Yeah.
2's are there? 1, 2, 3, 4.
4. Yes.
Here will be your 8. Here
8.
will be 4. Again you
8.
will get 2. So
Yeah.
basically, this average value of this E naught or constant value will remain same. So this will be, you can take outside of the average.
Okay.
So sine omega
Only
t.
for E naught.
Only for E naught, because E naught is the constant value. I have told you, na, E naught constant
Yeah.
value, maximum value. Now this is the average value of sine.
Yeah.
And remember, average value of sine, not omega t, sine of any. Sine, I
Okay.
am writing here for the omega t, sine of any, sine of omega t is equal to 0. So you can write this as E naught into 0. So what you are getting? Average value
0.
as 0. Very easy na now?
Yeah. Yeah.
And remember few more values. Average value of cos omega t. For full cycle, this is valid. For full cycle. I am
Okay.
again, not for the half cycle, is 0. And if you want to calculate the average value of sine square omega t, for full cycle, this will be equal to half.
Okay.
For cos square omega t, it is also half.
Okay.
And these all conditions are valid for full cycle.
So how will it be for half cycle, sir?
For half cycle, we have to do, for example, you have this sine square omega t.
Yeah.
Okay, if you want to calculate the average value of sine square omega t for half cycle, half cycle means 0 to t by 2. So you
Okay.
don't know the directly value. Actually, what you have to do, you have to calculate this value. You have to calculate this value by integration. You will do the
Okay.
integration from 0 to t by 2. Here you will write sine square omega t into dt. Here you will write 0 to t by 2 into dt. Then you will get some answer.
Okay. Okay.
So you can just write this full cycle. Okay, so in
Okay.
the starting, what we have done, we have calculated one RMS value. And see, this is very lengthy, na?
Yeah.
So now I am taking this. This derivation is lengthy.
Yes.
So we want to calculate the RMS value. Okay, we want to
Yeah.
calculate the RMS value. So I can write this thing, you know how to write the
Yeah.
RMS value. First square, then take the average, then take the under root. Square, average, and under root. Now this E naught square will be constant. This E
Yeah.
naught square will be constant.
Yes.
So you can take this. You can
Yes.
write this as, this is sine square omega t. And what I have told you, average value of sine square omega t, half. So put here
Half.
half. So this is E naught square basically. So see this, how easy this becomes.
Yes, sir.
E naught square and this is half. You
Yeah.
got the answer. E naught by root 2.
Okay.
So write down.
Done, sir. Done, sir.